Ashley Gozzo.
Yes.
And she is going to be telling us about the effects of white-tailed deer on forest understory at Weinstein Woods SUNY College Lodge at Jamestown Audubon Nature Preserves. Thanks.
Over the summer was on white-tailed deer and deer exposures. And typically in these deer exposures that I found in New York, with their ability to eat all of these variety of diets, they do dramatically change the species composition, reduces species richness, as well as alter the above and below grounds of the ecology of our forests, which then leaves these invasive species. Since they're less palatable, the deer do not want to eat them at all whatsoever. So these are most likely invasive non-native species. And with these non-native species, they tend to normally come over by accident or deliberate by human activity. So simply, you could be like, oh, I want this tree from Europe and bring it over. That would be now non-native, or simply you could go on vacation by accident and bring some grass up here and it plant. So with white-tailed deer, we do have a high population in western New York. And with their gestation period of 7 months, so they can have multiple litters. As well with the bucks, which is seen in this red bottom corner. And typically with the wild deer, they, without being kept in captivity, can live to 4.5 years. And typically what you can see them die of is blue tongue, and this is typically when a fly were to come in contact with them and bite them, as well as bovine tuberculosis, which is a chronic fatal respiratory disease, as well as chronic waste disease, which isn't very common in this area, but it can happen in deer, and this is a fatal neurological disease. But the most impact that we see is starvation. And with the starvation, since the plants are starting to die in the wintertime and they're not regenerating fast enough in the springtime, it is a major factor of why these species do not have a long lifespan compared to deer in captivity. Okay, so for these deer exposures, they are typically made to investigate the vegetation of interest. And with this, it will help regenerate our forest floors. And with that, it will keep the deer out so they cannot eat these native species. Typically, the deer exposures are 2.5 meters in height, and this is due to the fact that the deer can typically leap a 9 meters and 3 meters off of the ground. And typically they are made out of wood, as you can see in this picture right here, and there's metal fencing around. You can get nice starter kits, which start from roughly $1,000 off of line if you'd like, or you can simply build them yourselves. And these, in my study specifically, they're mostly 50 meters squared, but they do vary in size as well. So over the years at Fredonia, we had our first field research to make a hypothesis at our college lodge, where I was first to encounter these deer exposures, which made me think, you know what, this would be a great way to do some research on a topic that I really like. So I figured that with these deer exposure, that there would be higher plant cover richness and diversity inside of these deer enclosure for non-native plants than for native plants compared to non-native plants that would be typically found outside of these deer exposures. And with that, I also feel that the deer wouldn't be able to get to these more tasty treats, which will also help it regenerate the forest. Which next made me bring to my second hypothesis is with earthworms. Typically with earthworms, they are positively influenced by deer browsing. So with the deer browsing, there would have more of an impact of being shown into the soil. And typically, we do not have any native earthworms to this region. So with that, it starts to decrease our native seed population and survival growth. Even though that these worms do increase the amount of air and water into our soils, as well as take all of our organic matter and decompose that for the plants to eat, it's getting more benefited for our non-native species than for our native species. And that made me come up with my second hypothesis for this, that there would be more earthworms outside of the deer exposures than inside due to the herbivory of these deer. And these are the sites that I went to visit. Jamestown is down here, and this is Jamestown Audubon, which is located in New York. This is our SUNY Fredonia College Lodge, which is located in Brockport, New York, as well as Rhinestein Woods, which is located in Cheektowaga. At each of these locations, the plots were subjectively chosen inside and outside for the best representation of the vegetation in those areas. So for at Jamestown, we only had one deer exposure, which was built in 2000, and the quadrat size that we did there were 4 meters in square in size. And there was 4 inside and outside that was examined. As for our college lodge, we had 3 deer exposures, and these were all built by students at Fredonia, and they were built from 2014 and 2017. And these quadrants are a little bit bigger, and they are 16 meters square. And these only have 3 quadrant inside and 3 quadrant out. At Rhinestein Woods, we have 13, and they have been built in the range between 1992 and 2018. And some of these have been built by the local Boy Scout and Girl Scouts up there. And these quadrants were a little bit smaller than the other 2, which was 4 meters in square. And we had 3 inside and outside. And what was measured during these gatherings was the canopy cover of the spherical densometer, which is shown in that picture. So typically what you would do is I would stand over my plot, and I would hold it straight out and try to get it as level as possible. And as you can see right here, there's little tiny squares throughout here, and that is how I would get my canopy cover. Also, the richness is the number of species in the plot or community, as well as the diversity of the species richness combined with evenness. And we looked at that through the Shannon Diverse Index. And also we studied the amount of the invasive versus non-native plant species, as well as the arthropods and annelids. So for the fun part. So I got the pleasure of making the Burley's funnels. So I typically used a 5-gallon bucket. I had a collecting vessel, which had some alcohol in it for the worms to fall through. So typically, when doing this, you need a heat source. So as looking in the picture, I used a dome lamp with a 75 light bulb as my heat source. So as it dries the soil out, the invertebrates will start moving through that soil and fall into the collecting vessel, which then I was able to examine. And with this, 1 liter of soil was collected from each of the plots, but it was adjacent, so it didn't disturb to any of the inside that I was analyzing as well. And for this, this extraction was invented by Antonio Berlitz and also later modified by Albert Talgren. So for my analysis, each quadrant values in each of the plots were averaged inside and outside of the values compared with t-test. And all I have right now is the Reinstein Woods, which shows in the t-test. And also, we did one tallest tree sample out of the saplings out of the quadrants, and those t-tests were only based on Reinstein as well. Our earthworms, we did abundance of data that was also compared from the inside and outside, and those were done by a paired t-test and was only done at Reinstein Woods so far. So looking at the data that I have here, this is our canopy cover. So looking at it, the first two, you can see that it was less than 0.25. So overall, looking at all of the 13 exposures at Reinstein, we do have a significance that we do have more covered inside than outside, which is great. And also, which is also good, is that we have our native cover, which is significant as well, which shows that there is more cover inside than outside, which we hypothesized. For our non-native cover, it does not show significance. As looking at the graph, we can see that there is slightly more inside, but looking at all of the graphs, it does show that for the invertebrate richness and the earthworms that we did have some more on the outside, but not enough to be able to say that it's significant. Okay, so in conclusion, for Reinstein Woods, these deer exposures are making a great impact on restoring our vegetation cover as well as diversity and height. These findings show that the white-tailed deer do impact the vegetation that they graze upon as well as possible wildlife that is also in that area. And the invertebrate richness and density do not vary in treatment. This could be due because of the deer exposure being too small. And then for my acknowledgements, I would like to thank the Falcone Biology Endowment Research Program for giving me the funds, as well as the foundation, or Fredonia Foundation as well. Dr. Titus, who was helping me mentor and being able to identify the plants, as well as Megan and Ginger, who are at Reinstein Woods, as well as Jeff, who let me walk onto this property to do my research at Jamestown Audubon, as well as Connor and Layla, who are dedicated students to help me get my data. Thank you.
What were the initial habitats where some of these exposures were put? Because I would think that like an exposure in deep forest, you're going to see different diversity, different species than edge versus in the middle of the field or something.
Yeah, so these were all mostly interior in the forest, nothing around the edge. For Reinstein Woods, 3 of them were in their sanctuary, so it didn't have any human interaction, which those are the ones that I saw the most growth out of. And also, 2 of those were established longer than the rest of them, so those were done in '92. For the ones that were too public, you can definitely tell that there was more deer activity there by just the grazing upon it, not as everything was tight, but as well it could be from the fact that they weren't as old as the other one in the sanctuary.
You mentioned at Reinstein Woods you had quite a range of dates and when the exposures were built.
Yes.
Have you been able to look at time as a factor in some of your significant differences, and whether some of these differences grow greater with time?
I have not put those into my results, but that would be something to consider. I think it would, especially with the sanctuary, so I could probably split that data up.
Is there enough variation with, have they been built little by little throughout that
Yes,
time?
so I want to say the longest gap span was about 5 years in between putting new ones up. But for the one that was in there from 2009, that was kind of the best data with the most flourished.
Thank you very much. Okay, so our next speakers are Tony Lightshoe and Alex Stoff. They're going to tell us about a census of the bat population of Gannon University.
Hi everyone, my name is Tony Lightshoe and this is Alex Stoff, and we did our research with Dr. Ropsky at Gannon University. Our research was designed to determine the number and species of bats that used our little campus in Erie, Pennsylvania as a temporary home over the years. To start, here are a few fun facts about bats. They're only true flying mammals, and they make up about 25% of all mammal species. They live everywhere in the world except for the polar and desert regions, and that's because those regions don't have insects for them to eat. And they're nocturnal, so they feed at night, sleep during the day, and pollinate flowers and do all great things for the environment, but unfortunately, their numbers are declining due to something called white nose syndrome. White nose syndrome is caused by the fungus Pseudogymnostus destructans. As with any fungus, caves provide the optimal conditions for growth, such as wetness and constant temperature. And since over half of all bat species use caves for hibernation, that means over half of all U.S. bat species are in trouble. The fungus can be found on places on the bat, such as the wings, tail, face, ears, and of course, the nose, hence the name white nose syndrome. The fungal spores are viable for extended periods of time, so that means that it's able to spread easily. The picture on the top left right here just shows the fungus on the nose of the bat, and over here it covers the whole face. What's interesting is this picture right here, where it's on the wing membrane, and that can actually cause holes in the membrane of the wing, which is obviously not ideal for flight, and it can make the bat really inefficient at capturing insects. Unfortunately, that's not the only problem white nose syndrome induces. It also causes bats to wake up during hibernation, because it itches and they start scratching and then they start flying around looking for insects. But of course it's winter, so there aren't any insects for them to eat. So they don't have any food, it's cold, they can't thermoregulate, and they die. And unfortunately, this has reached 100% mortality in some caves. And since its discovery in 2006, over 6 million bats have been killed due to this white nose syndrome. Some biologists say it's the most precipitous wildlife decline in the past century of North America. This is the most recent map of the spread of white nose syndrome since its discovery in 2006. The dot over here indicates where it's first discovered, near Cave in Albany, New York. You can see that it spreads along the Appalachian Mountains, which is their migratory route. And you can see that, well, there's a little Erie, and we don't have white nose syndrome there because we don't have caves. But that doesn't mean we don't see the effects, because bats are dying and they're never making it to Erie. What's interesting are these marks over here, all the way across the country. Now, we don't think a bat flew all the way across the country like that. The theory is that a caver went to an infected cave somewhere around here, that big area, and got the fungal spores all over their clothes, and then went into a cave over here in Washington, and it spread there. The concern is that the white nose syndrome is going to spread down the West Coast and affect the West Coast species of bats. So why are we concerned? Well, there's a possibility of extinction of bats. 9 have been affected already, and 3 are already on the federally endangered list. The strategy at this point is to manage and conserve them, because there isn't a treatment that's effective enough yet. But why should we care? Well, bats eat agricultural pests and insects, and so if 99% of bat species are gone, that means there's 99% more pesticides that have to be used, which is not only bad for the environment, but it's more costly for farmers, since bats do all the free work of eating the insects, but the farmers would have to pay for pesticides. So what can we do? Researchers at Georgia State University have developed an antifungal treatment. It's called with the bacterium Rhodococcus reductus, which slows the ripening of fruit. And what they did was in 2015, they applied the bacterium to 75 bats before the winter, release them in the wild, and all 75 survive that winter. And what the bacterium appears to do is inhibit the growth of the fungus. Unfortunately, the problem isn't solved yet because you have to treat each bat individually, and that just requires an unrealistic amount of manpower. It's really inefficient. Some other things was this antifungal agent, chitosan, some antifungal volatile organic compounds, essential oils, and what they're also trying to do is try to make a device to be able to spread the compounds so we don't run into that inefficiency of handling each one, and hopefully this will just spread it to all the bats in the cave. And why downtown Erie? Well, Erie is a migratory stop for bats going north or south. So for the summer, they'll fly up to Erie, eat at Presque, and then they'll make their way across the lake to Long Point, Ontario. Around this time of the year, they'll be heading south again, and they'll stop in Erie to replenish their energy after the 26 open miles of Lake Erie. And right here is just the walk that we've done since April 1st to November 1st. And we look at about 70 to 80 spots on roughly 20 buildings, and we've done this walk since the first year of the study. When we find a bat, there's a couple things that we have to do. We have to record whether it's on the north, south, east, or west side of the building, the number of bats, and the species. If we can reach them with a ladder, we'll mark them with non-toxic washable paint, and that's to see if they use the same roost site, or if they go somewhere else, or if new bats come in. And the problem with the paint is that it does wash off in the rain. However, it's our best bet because the Game Commission has strict guidelines on the handling of bats. So we don't handle them because we don't want to disturb them. They're already stressed because of white nose syndrome. Rabies, that's always a possibility. And then white nose syndrome. We definitely don't want to handle a bat that has white nose syndrome and then get that on our clothes and then go spread it to other bats. And if we find a bat, that's how we mark them, which is a little bright dot somewhere on the body where we can see. So our hypothesis is that the number of bats in Erie area would decrease from the previous census due to the presence of white nose syndrome. Now I'm going to hand it off to Alex to talk about our results.
Great, thank you, Tony. So now I'm going to go into some results gathered from our campus here at Gannon University in Erie that supports what Tony was just telling us about white nose syndrome. We began this study in 2005 at Gannon under the guidance of our research advisor, Dr. Robsky, and of course other students were doing that at this time. And we've omitted the data from 2005 and we're picking up at 2011 because between those years the data was very consistent, with over 1,000 bats being found on campus between April and November every year. And this pie graph shows the percentage of unmarked versus marked bats. Again, some bats were left unmarked because they were in unreachable positions. So we do recognize that there may be some redundancy built into our data since we're not able to differentiate the unmarked bats from each other. But as Tony said, this is our best bet for conducting this type of research. And again, in 2011, we found over 1,000 bats on the route that we walk on campus. In 2012, the data was very similar, with over 1,000 bats being found on campus. And you'll notice on the next slide, the most precipitous decline. So again, from 2012, we had over 1,000 bats, and in 2013, we found only slightly over 100 bats. So we had a decrease of almost 1,000 bats in 1 year. And this correlates with the pickup of white nose syndrome across the country as well. And in 2014, we had another precipitous decline from over 100 bats to under 10. 2015, the data picked up slightly. There was a little bit of hope. And 2016, we were back to under 10 bats. 2017, similar low number. And now we're at 2018, and this is the data that Tony and I helped collect. And this year, we found only 6 bats on the route that we walk on campus. And we were able to mark 3, and 3 were in positions we were unable to reach. Next, we have some data looking at the diversity of bat species over the years. Every year, the most abundant number of bats was the little brown species, which is shown with the black part of the pie. And in 2011, we had some species diversity, with eastern pipistrelles and little brown bats as well. In 2012, we still had a similar amount of diversity. 2013, again, we had the huge drop-off in numbers, but we still had some diversity among species. In 2014, our diversity was reduced to 2 species, little brown bats and big brown bats. And that pattern is similar, continuing on until today. In 2017, we had 1 red bat, introducing a small amount of diversity. And this year, we found an eastern pipistrelle as well. But again, an extremely low number of bats overall. And the final type of graph we have is a line chart comparing the number of bats found per day. And in 2011, at the peak of the season, students on campus were counting over 70 bats per day. Again, in 2012, extremely high numbers. And in 2013, the highest amount of bats counted per day was hovering around 10. And from 2014 until 2018, most days were counting 0 bats, and the highest numbers are either 1 or 2. Or 3, but still, an extreme decrease from the over 70 that we were seeing in 2011. Only 1 bat per day at the most, same in 2017, and again, here's the data that Tony and I helped collect. And our final graph is comparing the areas that bats were found. So in previous years, you can see in 2011, the blue chunk is showing how many bats were found on each building around campus. And there have been some really popular spots over the year that I will go into in the next slides. But this year, bats were only found on 2 buildings, the Palumbo Academic Center and our old main building. And those who are familiar with Gannon will recognize those. This was a spot that was popular in previous years on our Communication Arts building. It's popular among bats because of the rough bricks that they can grip onto. This corner is another popular spot in years past because, again, there are the rough bricks as well as the shelter overhang, which provides shelter from wind and rain for the bats. And this year, 3 of the bats we found on campus were still in this spot. Our old main building is another really popular spot for bats because there are the rough stones they can grip onto, and there are also these metal bars. And you can see a bat tucked back here, and then one down here as well. Surprisingly, these metal bars are very familiar to bats, since many caves now are blocked off with similar bars, in part due to stop the spread of white nose syndrome. So many bats see these and recognize them as being from caves. This is another popular spot in years past. It's on the same building, and down this way is a little place that bats can fly into that is very cave-like. And there's also typically standing water here, which Tony and I hopped over to go investigate this area, which has lots of insects and bugs, which the bats really like. But this year, no bats utilized this spot. And this year, we did find 2 other bats on campus, but they were not on the typical bat route that we always walk, so we did not include them in our data. But they were both big brown bats, and one was found on a freestanding sign, and another little guy was found on a curb. One of the maintenance landscape people found him, so of course we went over. We marked him with a scheme of washable paint, but we did not include him in our data. This is a summary slide just showing the raw numbers again, and you can see that huge decline from 2012 to 2013, as well as another remarkable decline from 2013 to 2014. As you can see, the numbers have obviously decreased dramatically since we began this study. And a few questions to consider are about whether the little brown bat or the eastern pipistrelle will be moved to the state endangered species list. And in fact, before this presentation, we were informed that the little brown bat has been moved to the state endangered species list. Future plans include continuing this research into the 2018-2019 academic year, as well as taking steps to create a bat-friendly campus. These steps include community education and doing presentations such as these, as well as creating alternative roost sites for the bats. And pictured on the right is a bat house that we plan to put on campus in the spring. And this is a place where bats can climb as high or as low as they would like so that they can thermoregulate in the appropriate temperature. And we have 2 of these bat houses, again, that we plan to put on campus. We would like to thank Dr. Stephen Ropsky, our research advisor, as well as the students who have come before us. A few of their names are listed, who also helped to gather research and take pictures. We have several of our sources, and we also have time for questions if you have any. Yes?
With the bats that you are marking, have you tended to see much in the way of long-term residents on campus, and especially fidelity to certain buildings that individuals like to be on over the long term?
That's a great question. So for this year, we had a much smaller sample size to work with, but I would say at least half of the bats we marked returned to the same spot for 2 or 3 days before moving on.
2 or 3 days.
Yes, so it was not a huge fidelity period, but Tony and I are only working personally with this year's data.
Yeah.
Peter, I would say it's the same for all the years. They don't stick around much, 1 or 2 days max, move on. Yeah.
When, I might have missed it, when do you start doing the walking route? Like what month to what month are you looking?
April 1st to November 1st.
Yes.
Okay. Do you think that with a change in weather or temperature or whatever, do you think that's shifting, like happening earlier or later? And
That could definitely be a possibility with different weather, because I feel like they would do it based on weather because of how the insects move too, if they're leaving at different times.
yeah.
But we do have a pretty wide range there to hopefully capture that fluctuation. That even if weather is different, we still have a good several-month period where we're looking.
And then what was the year that you had the big drastic drop from like 11 or 1200 to 100? Was that 2010 to 2011?
2012 to 2013.
Is there something that happened on campus during that time? Like they installed new emergency lighting, or they did something that might have deterred the bats from coming to those sites on your spots? I don't know, that's probably before.
That's a great question to ask.
Yeah.
They're
Doctor?
looking at me. You see them looking at me?
Yeah, like you were there back then.
I was back in the dinosaur days. So what happened that year was that was the year that white nose first appeared in Cleveland, Western New York, the whole bit. So that was the year that it finally got as far east as us.
Oh,
Yeah.
okay. So there is a good relationship.
Yes, right, yeah.
Yes?
So I have a question about the bat houses. So if this is spread in caves, and that presumably means that the bats are all together, is putting space out for them to congregate closely together a good technique? Has that been proved to have a detrimental or positive effect for bats?
That is a great question as well.
I'd say that'd be what would probably look at, because we haven't done it yet, so we'd like to see if it would help, and I guess, or hurt. Hopefully it helps.
Yeah.
But we're just trying to draw them in so they know they have like safe spots to be in.
And I would say, and another response to that question, that since white nose is a fungus, those spores can travel very far as well. So even if bats aren't staying in close proximity, there's still a risk of transmission regardless. Yes. Anybody? I'm not sure what our time is.
I was just wondering with the idea with the bathhouses and you mentioned about the hand applying bacteria to help control the fungus. Have they looked at any sort of brushes or systems that as the bats are entering or leaving so that it doesn't have to be manual? The bats are basically applying it to themselves as they come in and out.
So there was research into the nebulizer kind of apparatus. It was sort of like an air diffuser. So that kind of really goes into your idea, to have something as they're going into or out of a small space.
I'd say it's tough because a lot of bats have different entrances and like places that they leave through from caves. So if you pinpoint one and it upsets them, they could probably find a bunch of different spots.
Right, I know with like a cave it would be different. I'm just saying with like something like the bat house, it might be more controlled.
That's a
Yeah.
possibility.
Yeah.
It'd be something
I
like
think
that.
we have to realize that the little bat population statewide is down about 98%. And it's basically due to white nose syndrome. And the more we disturb the bats, the greater risk we have of them increasing mortality, simply because they got limited energy. So what we're recommending right now is that all winter hibernation areas be gated. So bats can get in and out, but human beings cannot. So they would not be disturbed during those winter months. I don't know if it's ever going to come about because a lot of those are on private property. And a lot of them are commercial cases. So
One of the latest ideas is on the caves. They're completely closing off the caves and just having a little slit.
right.
And the bats will fly through there, and the bacteria will be sprayed on them above and below, like going through a car wash. So you're going to try that next and see if that's a possibility to spray it instead of having to hold it in your hand and spray.
Thank you very much. No, you did. You're fine. Our next talk of the afternoon is differentiating between native American bittersweet and invasive Oriental bittersweet using morphological and germination parameters by Connor Mosh.
Hi, so I'm Connor Mosh. I'm from the University of Fredonia, SUNY Fredonia in Fredonia, New York. Yeah.
Thank you.
You're welcome. Hi, my name is Connor Mosh. I'm from the University SUNY Fredonia in Fredonia, New York. And I'm a senior in biology and psychology, and I'm working with Dr. Titus, our plant ecologist. So my presentation is called Differentiating Between Native American Bittersweet, Celestris scandens, and the invasive Oriental Bittersweet, Celestris orbiculitis thumb, using morphological and germination parameters. So that's quite a mouthful. So I'm going to refer to the native from now on as scandens and the invasive as orbiculatus. And before I wanted to talk about specifically my research, I wanted to introduce the broad topic of what era we're in and how this research is important to the time period. So you might have heard of the term the Anthropocene or anthropogenic effects. And so this is in reference to human alterations to the landscape, so the biota, the climate. So if we have any climate change deniers in the room tonight, you might want to tune out at this point. We have, but it's it's a proposed epoch. It's not something that's deathly specific. But we do have the relative knowledge that we do have an impact on the world around us because as the primary apex species on Earth, we have vast population growth. So the graph on the left of the screen, you see human population in purple, plotted against extinction rate in green. And on the right, we have human population growth. Dark blue is up to the current period, and light blue is the projection of human growth in the, I believe it's 2100. So you might say correlation is causation, but we are the apex predator on this Earth, and the vast human population, billions, is going to drive natural resources. It's going to have significant influence on the Earth. So there really isn't much question about how we are influencing the extinction rate of species on this planet. So we can see the general estimate for how many species you would expect to be going extinct per year is usually only about 1 to 3. We're seeing thousands upon thousands of species, and many that we may not even know about yet, because we're still discovering species every year. So yeah, it's kind of dire times, more or less. Now, the definition, I guess, for invasive species would be by the USDA is non-native or alien to the ecosystem under consideration, and their introduction causes or is likely to cause environmental harm or also human harm. So you guys might have heard of giant hogweed. Anyone heard of that? Yeah. So that one has a phototoxic chemical. So if you touch it or get into your eyes, it will go blind and cause second-degree burns. So that's an example of an invasive that people are readily willing to talk about and get rid of. But there are tons of invasives that we have that we don't really do too much about, or we don't have a lot of public knowledge of. So you may or may not recognize the bottom left is garlic mustard. So here, don't eat it, but it's readily, you can find it just about anywhere, whether it's in your yard or in a back forest, woodlot. But because deer don't eat it, it's a competitor with other native species, and it can cover huge swaths of land. So, so that's an example of invasive because it has a compensatory advantage over a lot of natives. Now, there are non-natives, and sometimes I feel like there's natives, non-natives, and invasives. So invasive and non-native are not necessarily the same. So this is zinnia flowers. They're native to Western America and South America. And because they're non-native, it's because they don't really pose a competition to native species. So they don't really take over the landscape so much because they're also reduced by deer browsing significantly. So they're not really posing a threat to the native environment. They're probably in your grandparents' flower bed. It's no big deal. Here pictured is the native species, Celestra scandens. It's a flowering woody vine that's endemic to North America. It can reach a height of about, it's pretty typical. It's primarily dioecious, which is really interesting. So they have male and female plants. So they'll have male flowers. You'll usually you find, I believe it is, one male plant for every 7 females is the greatest reproductive success in an area. They prefer little to no shade, so they're usually found at the edge of forests, or in forest openings, or cliff sides, or embankments, riparian zones. And they produce very large, show yellow fruits. So in the early, they start fruiting around end of August, and they continue growing, and they ripen into these beautiful red berries. So they're also used as ornamentals. So the difference here is that they show at the terminal end of their vines. The fruits are poisonous to humans, but they're readily edible to birds, deer, etc., and other species that can then spread the seeds to other areas. Now, Oriental Bittersweet, this picture is taken on SUNY Fredona's campus, actually. I found this on the parking lot edge. And they're a flowering woody vine, so they're endemic to Central East Asia, so China and Japan that they can be found in. They're also dioecious, and one significant thing about them is that they're tolerant to shade, so they can be found within closed canopy spaces, which is different than the native. They also produce the similar show yellow fruits. They tend to be smaller than the native, so that's something that you notice. They're also poisonous, but their seeds can also be readily eaten by the species. So most species that eat the native are also going to eat the invasive because they look identical. Now, identification is one of the tricky things about it. If you notice my title, that's part of what I'm working on. So here we have scandens, and it can be easily identified when it's flowering or fruiting. So in this picture shown, they fruit and flower at the end of the terminal end of the vines. While if we look at the invasive, they fruit and flower across the auxiliary panicles of the leaf stems, so across the entire vine. It was actually interesting, there was an example of orbiculatus upstairs shown by where the posits were being presented. So there's a time-sensitive period of when you can identify them, which is part of, one of the things is if you want to remove an invasive from your environment, it would be nice to know at all times of year which ones are invasive and which ones are not. So you don't want to remove the native species. So yeah, they pose a significant harm, and they're one of the most significant invasives, even though they don't seem to be necessarily as significant, because they can roost in closed canopies, so you might not notice them for long periods of time before they come into more urban environments. So they can outcompete the native. They can choke out forest understories, so not only do they necessarily outcompete the native species, but they can also reduce growth of other trees and native species of other types, because they, as a vine, they can completely cover sections, and they grow extremely fast, and likely faster. That's one thing I want to investigate, is how the rate of growth versus the native and the invasive is. Another significant factor that they found is that they can hybridize with the native. So we can also have an issue of the native going extinct, because the invasive can reproduce with it, and if it produces, if we get a higher volume of the invasive, the native can, any genetic markers for the native can be more or less exterminated. So for leaf morphology, there appears, and this is something when I was in the field I was trying to investigate, there appears to be some difference between base and terminal leaves. So on the left is scandens, terminal leaves, and on the right is orbiculatus base leaves. So I'm trying to investigate if there is a significant difference between the terminal leaves of scandens and the base leaves of orbiculatus. Because I have been noticing that, and it might just be our area, we might have morphological differences within this region, because a lot of the papers I was looking at were in the Midwest, in Indiana particularly. But I've noticed rounder leaves toward the base of vines as compared to scandens, which didn't have as dramatic difference, as a dramatic difference of rounder leaves at its base. So I'm going to or measure leaves on those factors. So my hypotheses going forward, Oriental Bittersweet will tend to be taller than American Bittersweet. Oriental Bittersweet will tend to grow in more shaded areas. Oriental Bittersweet will have a leaf length width ratio closer to 1:1, that being rounder, between base and terminal leaves than American Bittersweet. Oriental Bittersweet will grow faster in both shade and non-shade conditions, and American Bittersweet will have larger fruit volume and more seeds per fruit. And from another paper I read about, Oriental Bittersweet will have greater germination success. So my field methods, so I'm just finishing up my sampling methods. Actually, after this talk, we're going to go investigate a local population in this area of orbiculatus. But I'm going to be measuring diameter of the vine, about 10 centimeters above the base. Height of the plant will be measured, or estimated with a meter stick, because some reach significant, especially orbiculatus, I've noticed, have reached much greater heights. Shade is going to be measured. I'm also using a shade densiometer, so it's a chrome plate with 25 quadrants, and I can measure shade percentage. Leaves will be sampled with 5 from the base, 5 from the terminal end of each vine, for comparisons. And I'll take 10 fruits across the plant, so that, as I'll be measuring, more specifically, I'll be measuring, because they found that orbiculatus has smaller fruits, generally speaking, so I'll be measuring those by displacement. And also seed number per fruit. If a native plant is too small, I will reduce the amount, because I don't want to harm the native population. Orbiculatus, I'm cutting them, so I can take as much from each plant in that case. And also recording locations by lat and longitude. So here are some field locations in New York that I've been to thus far. So up here we have Sanger Farms, the Whirlpool Gorge in Niagara. So these were some heavy native populations I found here. And some more invasives, we have Greystone Preserve here, Zor Valley, if anyone's been to there, it's a beautiful nature preserve. And some also local locations on campus and at the Dunkirk and Ratio Park. Here pictured is, this is the Whirlpool Gorge. It's a beautiful park. If you ever get the chance to go to Niagara, I wouldn't recommend just going to the waterfall. I recommend going a little bit further up. Because this is I mean, there's great trails here, and also I found a huge amount of the native population within that area. And something significant that should be noted is, well, if they can hybridize, how do I know I have the native? That's most of the assumption would be that if I can't find invasive in the area, I'm assuming that they're native. So my lab methods, measuring leaf ratio. So basically it's simple. Width, I'm just choosing at the highest point of the width. Volume of fruits will be measured by displacement. So I'm using a burette at actually about 1/10 of a milliliter. Seed number is going to be counted. And so I also want to take these seeds in the springtime and germinate them in our greenhouse. So I'm going to measure growth rate and germination percentage. I'm going to have a shade and non-shade condition. So see how much better the invasive performs in shade and non-shade conditions. Because that's one hypothesis, that invasive, no matter what, is going to outperform the native. Here's a picture of the greenhouse. So this project is, I'm just finishing the sampling portion. I'm working in the lab now. But the greenhouse experiment will take place in the spring of 2019. I have some preliminary results of what I've measured so far. So here we have height, diameter, and shade. I did a note between the two species. Now, the only thing I found significant thus far was shade percentage. So the orbicularis was found in heavier shade regions in a significant fashion as compared to the native scandens. Height was also, though not significant, it was noted that orbicularis was generally larger than the native. So. Okay. And I would like to make acknowledgments. Dr. John Tynes for aiding me and helping me in much of this project. Falcone Endowment, Sudi Wang for Siltitis, Eric Danielson, Ashley Gazzo, TJ Jennings, Layla Crabtree, Gerard Harada, Caleb Costa, and many of the others who have been helping in the process thus continuing. All right. Thank you. Any questions? Yes.
So I don't know your sites at all, but is there any difference between, I should say, are you looking at the amount of both? So, and is there difference in if it's been disturbed?
The amount of species in each area?
Like the amount of the native versus the invasive, something like that. And is there any thoughts of like looking if the area's been disturbed or like how much disturbance there is?
In particular, we've been looking at some of the other species that we're finding around it, but I'm not really able to compute that, so I haven't had that analyzed by any means. But I'm noticing the pattern that they are being found in the expectation of like forest edges and cliff sides, and orbicularis is being found in deeper portions of forests. But I'm not analyzing between those.
Could you just repeat your last sentence about
Yes?
cliff sides and forest edges?
Yeah, so I'm noticing that scandens is tending to be at forest edges, so in less shaded areas, that is. So as I found, they were less, native was significantly less shaded. Orbicularis, the invasive, had significantly more shade. So it was found in deeper portions of the forest. Does that make sense?
Have you found any populations where they're both there together in the same area?
No, not this far. So that would be lucky, but I'm sure there are regions that they are. One area I did find, and I didn't include the data actually, they were, I believe the distance was about more than 100 meters apart, where I found 2 orbicularis and then a population of scandens. So they are definitely able to be within the same region in our area. Yeah.
Have you read, is there any difference, if they can hybridize, is there any difference or advantage that those hybrids will have over, over the native species?
Yeah, no, interesting. So the hybridized, the paper that I read on that was actually pretty recent. I think it was only about 2009 or so. So they haven't investigated, I don't think, about the growth rate or the success or advantage so far, from what I've seen at least. And also, about morphology and difference between them. They did find, they would have growth on both the terminal and auxiliary ends of them, so they would have a mixed kind of a medium type. Thank you.
Is there like a background you want me to put? No. And last up, we have a speed talk by Rowan Baxter Green, who's going to tell us about shallow wilderness, working to expand interest in suburban ecology.
Hello everyone, my name is Rowan Baxter Green. I'm coming here from Allegheny College, and today I'm going to talk to you all about my work on suburban ecology. Now when I say suburban ecology, I mean the little wildernesses that exist all around us, from birds at a backyard bird feeder to dandelions growing up out of the cracks in the sidewalk. Most people, when they think of wilderness, think of places like Yosemite and Yellowstone, places that have huge stretches of undeveloped land. But here in the US, most people don't live in places that are anything like Yosemite or Yellowstone. In fact, according to the 2016 census, about 175 million of us live in suburbs or small urban centers. Our chances of seeing wolves on an average day are pretty low, but if we're lucky, we might see a blue jay. These suburban ecosystems might not matter much for larger wildlife conservation issues, but what they do have going for them is the potential for enormous social impact. We interact with nature every day, but because there are biases towards thinking about nature as pristine and untouched by human hands, we don't always see it. If we can make people see this kind of nature and make them care about it, then we can show people how nature intersects with their lives on a daily basis. Think about that mandarin duck that's floating around in Central Park right now. People who wouldn't normally go to the park are now, pardon the pun, flocking to see this exotic bird. But what if they were this excited about an ordinary mallard? What if the people in one of the densest cities of America took time out of their day to look at the trees planted along the sidewalks or the pigeons on the roof? Would that make them care more about the world that they live in? This is the part of the presentation where I expose myself. My work is not traditional scientific research. What I'm actually doing is creative writing. I am, in order to make people recognize and care for the nature that exists all around them, I am writing a series of creative nonfiction essays. These essays are centered around my time growing up in suburban New Jersey and how interacting with the tiny patch of woods in my backyard helped shape me as an environmentalist. And if you've never been there, New Jersey's about as suburban as you can get. That's what happens when you wedge a state between New York and Philadelphia. But even though the two biggest features of my hometown are a shopping mall and a super fun cleanup site, I still found nature all around me. And if you can find nature in New Jersey, then you can find it in your own backyard. So why use writing as my approach? Well, I am a writer, and I might as well use the skill where I can, since my English degree apparently won't get me anywhere. In all seriousness, though, literature allows scientific thought to reach an audience that papers usually can't. Not to disrespect your work, but scientific papers are widely accessible to the general public because they're published behind paywalls and written in dense language that people outside the field can have a hard time parsing. Far more people have read Silent Spring than have read the reports of the research that inspired it. Beyond that, literature fosters an emotional connection to the subject matter. It can make people take things to heart in a way that a paper can, whether that be through good prose or personal anecdotes. But I'm not just going to tell you all this and expect you to believe me. I'm going to read you an excerpt from one of my essays and let you hear it for yourself. Last night, my mother finally did the inevitable. On her drive home from work, she hit a deer that ran in front of her car, too fast for her to even brake. The levels of damage go like this. Mom, completely fine. Car, banged up, but still drivable. Deer, well enough to hobble away, but perhaps not well enough to survive long after that. In my mother's words, the deer came the heck out of nowhere. And maybe from her perspective it did. But deer just don't spontaneously appear on roadsides to jump in front of your car. The deer had a reason for being in that town, on that road, at that time, just as much as she did. White-tailed deer are native to New Jersey, as they are to most of the states in the continental US. Though commonly found in wooded areas, they're resilient enough to live in neighborhoods and on golf courses, where they can eat trees and shoots that other animals can't reach or digest. They're most active at dawn and dusk when the light is faint and low. Early November is right in the middle of their breeding season. My mother drives home from work around sunset, depending on the season, of course. Her route takes her past a park, on a narrow wooded road, and through some suburbs. Every mile of it is a deer's paradise. The deer didn't come out of nowhere, it came from its home. Where then do we place the blame? If this is a case of wrong place, wrong time, then who was it who was in the wrong place at the wrong time? Or is there no blame to place? Maybe this kind of experience is just part of the suburban cycle of life, the logical next step for the deer after they eat their way through my mother's garden. The deer is not a pest and my mother is not an invader. They are just both living in the place that they call home. Thank you all for listening. If anyone has any questions, please feel free to ask.
That was great. And I guess the one thing that I would say is that, something we don't talk a lot about at this conference is science communication. And I think that science communication is, at least for me, my perspective, is something I always need help with when I'm trying to reach out and help people understand what it is that I'm doing. So, question for you is, it sounds like you're in a writing courses. Are you working with anybody who's specifically thinking about science communication in your program?
Yeah, that's a good question. I'm a double major in English and environmental studies, and Allegheny College is actually pretty good about having programs revolving around environmental literature. So we have like a full-on environmental literature course, which mostly focuses on like the creative aspect, but there have been scientific communication courses in the past. We actually have 2 English faculty members whose specialties are, one of them is my advisor and he focuses a lot on Appalachian studies, and one of the other professors is very focused on animal studies and literature. So we do a lot of interdisciplinary work there.
I have a comment. So as the director of this conference for the last 11, 12 years, thank you for presenting, because that has opened a whole new door to this conference. And coming into coming into this conference with a different perspective and a different talent, yeah, kudos to you. Thank you for applying. I really appreciate you being here.
Thank you. You can blame Eric Appellant for that.
I will.
He's the one who sent me here.
I second all of that.
Thank you.
Well, thank you all for being here today. Up now is a green building tour of the Tom Reed Center, followed by a tour of